Hi, everyone, and everyone here. Welcome back to EXAG for the final paper session of today. Right now, we're going to be doing a series of short papers, which are 15 minutes with question and answer. Do you have anything you want to say?
Yeah, so there are going to be four more presentations this afternoon. After that, we're done for the day. We'll resume tomorrow morning. As a reminder, if anybody has questions, writing them down on sheets of paper so we can read them out to the stream and not have our presenters reread them would be great. But again, feel free to ask anything.
Especially because these talks are going much faster than the previous ones.
Yeah, and for those of you presenting tomorrow, if you haven't gotten Joe your slides yet, please do that by 9 a.m. tomorrow morning.
Yeah.
And I think that's it. So
yeah. Let's get our first session started. And here you are.
Thank you very much. Hello, everyone. Thanks for being here. My name is Sergio Hernandez. I'm from the University of Alberta, and I'm here to present on behalf of the rest of my team the paper on deep learning for speech accent detection in video games. The rest of my team is Astrid Ansley and Tejasvi Gurimurthy from the Humanities Computing Department in the University of Alberta, Shelby Carlton from the English and Film Studies, and myself and Dr. Vadim Bulitko from the Computing Science. So what are we trying to do with our work? So we are interested in examining how accents of English are used in video games, how they are used to perpetuate or not different dominant linguistic attitudes. And this is basically doing a context analysis of games through a game clip database and the metadata for that. From the computing side, we're interested in helping automating this process, basically with the game clip database. And we are interested in using speech accents archive data as a training set and apply this, train a machine to games like Dragon Age to try to differentiate the different accents used in the games. And our question for this paper is, how accurate can we get with this accent classification? And the end goal is to inform of this kind of studies to inform game design, try to have great diversity, inclusiveness, and avoid stereotypical use of accent speech. So this study is an extension of a previous pilot study made by Astrid Ansley, where she was looking at how accents are used in different games and how in English you have this phenomenon where a lot of the hero called the Pax Americana, where the heroes are usually given American accents in their games, and a lot of the villains have other kinds of accents, British accents, Russian, Chinese, so they're very stereotypically used. And how, here I have a picture of Scar, because Disney movies are known for doing this, with the villains having British accents and the heroes having the American accents. So this study was done by, like I said, by Astrid Ansley, and she went through clips from different video games like Castle Wolfenstein and Black and White, manually trying to see where the different accents were used. So we want to help automate this process with the labeling of the audio files in the games. And we thought of doing it through deep learning. So for our method is basically we're interested in using a pre-trained network, in our case AlexNet, to differentiate the different accents. Since AlexNet is a visual and image classification network, we need to transform the audio files into visual representations, into images of them. And we do that by doing spectrograms of the audio files. Here I have an example of one from the Dragon Age games that we're looking at, and I'll play what this sounds like. Hopefully it'll play out well. So this is in a tavern in the Dragon Age game, and that audio translates to this spectrogram that I have here. So our goal is to gradually try to increase the accuracy with which the machine will be able to differentiate between the different accents in the video games and appropriately label them, so automating this process and helping with the analysis. So how we went on to experiment and to validate this is we first used the speech accents archive from the George Mason University to train our network. The reason we were using this database is because it's already labeled with all the metadata, and it has a variety of non-native English speakers in it, so we have a variety of accents on it. The way we went through it is we divided it into training and test sets. Each of the files are about 20 seconds long. So since creating them into a single spectrum would lose some information in it, we decided to go with 3 to segment each of the files into 3-second segments. So approximately 7 segments per file were created. The reason we went with 3 seconds is we tried we tried different sizes, and 3 was the one that was giving us the best results. We create the spectrograms for each of the segments, and we resize it to a 227 by 227 pixel image, which is the input for the network. And also, we're using 67 files per class, and we're interested right now on 3 different accents: British, American, and Spanish. Part of it is because these are accents that are known to be in Dragon Age games, and also because those accents were the ones that we had more. There were more samples of them in the database. Then we applied, once we trained the network, we applied it to the Dragon Age audio files, from which we had a total of 17 files. And these files were processed the same way as the speech accent archive files, segmented to 3-second chunks, and then spectrum for each one. But for this data set, because it's in the beginning of the game, we only had access to 2 different accents, British and American. So the network was trained for 3 accents, but we applied it just 2 later on. Here's a little bit of a sample how the spectrograms look from the speech accents archive. I have on the left a British one, and on the right the Spanish one, and this is from the same time chunk of the phrase for each one. So there's some differences between them that we can see. For example, here we see some red where we don't see that kind of intensity on the other side. So there's some difference, and we were hoping that the network would be able to train on those. So for our results, the network accuracy for the speech accents archive was around 70% accurate. We thought this was really good, considering that our random classifier would be around 33% because of how the data was separated. Here we have a confusion matrix to see how the different classifications went on. So the columns represent what the actual labels were, and each of the rows represent what the network classified them. So here in the top left corner, the British is in the first column. It's all the British files, and of those, 61.3% were classified as British, 20.1% were classified as American accent, and 18.6% were classified as Spanish, and so forth with American and Spanish. So we were feeling really good, and we went on with the Dragon Age Origins data set, but with this, the results were not as good. As you can see, it was around 9.5% accuracy, and also considering that here the majority, like the random classifier, was around 52%, so it's way worse. And most notably, most of the files were labeled as Spanish, which was not even in our database. So we started looking at what could have been the causes for this. We came up with a lot of theories. One was like the Dragon Age Origin audio files had background sound when the speech archive didn't have any. So there were a lot of things that we were trying to do. The first thing that we said we were going to do, the first step to try to correct and figure out what was going on, is try to simplify the problem. Instead of training it for 3 accents, British, American, Spanish, and since we didn't have any Spanish in Dragon Age, and that was the one that was giving us the most problems, we decided to take it out and just focus on American and British. So we retrained the network, but now only classifying with British and American. And the network accuracy, the results for this, the network accuracy with the archive was now 75%, which is an improvement, but consider also that the majority class, the random classifier, would also increase to 50%, because now we only have 2. More importantly, the accuracy network with the Dragon Age Origins files increased to 52.7%. Huge improvement over what we had before, but still not significantly different than just random classifier. So again, not good improvement, but not the kind of improvement we wanted to see. So we started doing some more analysis. So here I have the spectrogram again of the file that we just listened to a bit ago. And here I have what the network is saying at each of the different chunks of time that we had. The blue is British and the red is American. So this file was classified by our team as American, the whole file. And you can see there are points where the network is classified as American, but for the most part it's going through with British. So this started us to think that what could be the reasons for some of the reasons happening. So, and that's sort of what we want to do for our future work. Some of the things that we are thinking about is looking closer to the authenticity of accents in video games. Sometimes companies will have American actors trying to imitate a British accent or a Russian accent, and in the middle of their recording, they might drop the accent. So that might fall into one of the chunks that we had. And this came up a little bit when we're trying to label the data. The people labeling it would be like, oh, this is an American accent. Then someone else would hear it and be like, yeah, but when they say this word actually sounds British, but the rest of it is American. So there's this kind of elements that we have to consider into it. Also, another thing is the impact of how the speech accents archive is set up. For all the files, all the participants of that archive are saying the same phrase. So it's quite possible that we're trained the network to differentiate the accents for that particular phrase, and that doesn't translate to a more varied to more language vocabulary. Of course, we hope to do all this to improve the performance of the network, not only with the current accents, but also we want to be able to do it with more accents, start adding French, Russian, Chinese. And once we have this, also apply this to the end goal, which is how to begin doing the analysis of how accents are distributed in games. So just to sum up, what we wanted to do with this project was examine how accents of English, different accents of English are used in video games. To help this process and automate it, we trained AlexNet network to differentiate the accents. We trained with the speech accents archive, and then tested this trained network with Dragon Age Origins. And the results are mixed, to put it kindly. So, and for an analysis is needed on the audio side, how to modify the network or even the spectrum creation. So, if you have any questions. Awesome.
So I do have a question.
Oh, yeah.
So, like, you talked a little bit about sort of these audio that you're training on. Like, what was this like? Just audio when you were like sort of running around the overworld in the game, or was this like during conversations between characters?
Oh. A little bit about, we tried to capture conversations with characters. The person on our team who was collecting the audio was playing the game and was recording when there was any conversations between with the NPCs that they found interesting and that they felt were clearly showing the accent of the character. So yeah, we were trying to find it from actual conversations with NPCs.
I also have a question.
Yeah.
So one of the things I saw was with the chunking, you had different parts being classified as one versus the other. Do you think with different accents, and I'm not a linguist, and I'm sure a linguist would have a better idea than me, there are like certain features that are more salient for classifying accents than others? Yeah, actually, and that's part of like, we are working with someone who knows more about audio linguistics, asking them a little bit more about that. For example, one of the things that he mentioned is, for our chunking for the 3 seconds, we did try with, for example, 1 second chunking, but the results were even worse than when we did with the 3 ones. And he actually suggested to go even smaller than 1 second chunks, because he was saying like, oh, with the 3 seconds, the information you're getting is the contours, so the contours will help you with the archives, but they won't necessarily translate to the Dragon Age, because you won't get that that much fine detail that you might need, because again, it's the same phrase over and over, right? So you're just seeing the contour of that. You're not getting the
the accent-specific things. So that's one of the things that we're trying to do, going with smaller size windows chunks.
Awesome. One more question?
I think we are trying to do some classification on essence, right? Because
Yeah.
in the machine learning conference, they have already published some results about the essence classification results. So I just don't understand what's the difference between your work with their work, because their work they are trying to classify different languages. So is there any difficulties on your particular problem?
I honestly haven't seen that paper, so I wouldn't know exactly what the difference would be that you're referring to. Yeah, we can talk about it offline.
All right, and with that, thank our speaker.
Thank you.
Boop. Okay, what do we have next? We have, the Dell, which is this one, which I believe it was Control L. Yes. Cool. Get the mouse over there. So you're in focus.
Okay.
Next talk.
Okay, thank you. My name is Javier Torres, and I will be giving a talk about dynamic epistemic logic in game design. Why should we care about this field? So let's jump into dynamic epistemic logic. What can it be used for? What's it about? Imagine we have an action RPG in which we have a couple of heroes in front of an alley, and then they listen to a voice that says, if you get into the alley, come in, you'll be safe. But in fact is that the heroes here, one of them, is doubting, they doesn't know whether they will be safe into the alley. And this indeterminacy comes from two sources. First, they don't observe all variables, so there's one possibility that there's someone around the corner with a couple of knights ready to pounce on them. And the other source of indeterminacy is what happens if I engage in a fight with a potential enemy. So I may win or I may not win. So at the end of the action, both results, both outcomes may happen. So we have a logic in which we have an epistemic modality that defines what we know or we doesn't know about the current state, about the range of all plausible states that we are considering. We have a dynamic modality which expresses which things are true or false after an action has taken place, given some preconditions, and then we have some base propositional or first-order logic about the facts themselves. How is Dell different, or what are the features that could be used in game design? First, we have said that there is a bimodal logic with a clear specification of the results and outcomes of an action. It includes a specification of what an agent knows or doesn't know, the limits of their knowledge. It has a very active theoretical development with connections to different fields like planning, some other modalities which we will talk about later on, algebraic models. And there are some already ready-to-use implementations. For example, Jan van Eyck's demo checker, Melvin Gettinger's SMC-Dell, and as I learned in the conference, Egger and Martin's study, which will be presented next Saturday, if I'm not wrong. So, talking about previous approaches, we can mention Rao and Georgiev's belief, desire, intention, which is very ambitious, but unfortunately most implementations do not go so far as to reason about the beliefs and the goals, and just make use of a very simple fact database and perform a very simple forward or backward inference. We have also seen some game designs making use of action specifications, for example in Versu, in which agents do have their actions specified and use some kind of utility mechanism to select one of them. And their narrative is advanced through this action taken. Facade has a similar setup in which the agents may take actions which are shaped by the narrative or help shape a narrative. And we can mention as well Horse's MK Ultra when talking about knowledge manipulation or belief manipulation. In this case, we can insert facts into the fact databases of agents so they reach some conclusions. And I think this is quite an illustrative example. And I quote, the NPC is in orange and is also very hungry. The NPC will obligingly commit suicide through auto-cannibalism, thereby freeing the PC to inspect the house. It's a very interesting possibility when it comes to manipulation of what another person is thinking, albeit is a very direct one. We can also mention the work of James Ryan, both on belief propagation and social networks, and also in Hebbian-like schema association, so that schemas that appear together tend to have a stronger association. And Camilfo by McCoy and colleagues, in which there are also formal specification of actions, social exchanges in this case, and again the actions are selected using a utility mechanism. Doherty, Kvanström, and their collaborators use a temporal action of logics, to which they start adding an epistemic model, but they don't go so far as to detail it too much. So if we have some specification of actions, we have, and we can talk about the knowledge of the agents as well, how can we use this in games? For example, and using the patterns described by Trainer and colleagues in their AI design patterns paper, we could, for example, use an AI as a villain, in which we have a player detective that tries to spot some unexpected knowledge from a suspect by making questions. And in fact, it can be turned against us, because we may don't want to make some questions that may give away some information that we don't want the suspect to have. And the prototypical example is, for example, when using information that we have obtained through a mole in, for example, in a gangster organization. We can also use it in an AI as an adversary, in the sense that we can plant doubts in the reasoning of other agents. Imagine an RTRs or a 4X game in which we advance troops to some border of our territory and another player's territory. Then we might say, we have been suffering the attacks of brigands from this side of the board, so we plan doubts as to the real intentions of our actions, so that the NPC cannot directly infer that we are going to attack the territory. And these are nice possibilities, but I think that's what more intriguing is that there are already quite a number of theoretical developments, not yet into implementation, that tie dynamic epistemic logic to other fields or other modalities. For example, in planning, there have been some extensions using dynamic epistemic logic in planning, so that we can perform sensing actions. For example, the agent knows that it lacks some piece of information, so it plans to make an action that will allow them to definitely know or know its country of that piece of information, instead of resorting to replanning or planning to contingencies in the plan it's building. We can also add goal modalities, so that agents, we can reason about the goals that an agent may have, so that an agent will take the actions that directly advance to their goals. And it could be interesting, for example, to give information to an agent so that that agent will take an action that will drive them to a goal. That will have, in turn, beneficial side effects, for example, for the player or other NPC. This is a kind of manipulation, and it's even more interesting when we are considering probabilistic action models, so that the outcomes of an action do have some degree of probability of appearance. So if we influence the estimate of the probability of an outcome of an agent, they might take one action or another, which could be a much subtler form of manipulation. We could also add in temporal logic to reason about what we have seen in the past, or what one agent knew in the past, for example. Did it have the knowledge or the piece of information to commit a crime? Did it know where the knife was to murder someone. For example, we can use interrogative logic in which the agent poses questions in the edge of their knowledge and can be turned into an AI is guided or AI is spectacle, depending on the kind of information we feed it, useful or inappropriate. And maybe as we mix in different modalities, we might, and this is just a possibility, we might be using it as a kind of a basis for a logic language from which natural language can be translated instead of plain first-order logic. So, as a conclusion, I would like to say that dynamic epistemic logic is the logic of actions and knowledge with a mature theoretical development. It is a very active field with connections to other modalities, fields like automatic planning, algebraic logic, natural language. And there are some preliminary reasoners to be used with good performance, like SMC-DEL. So I would like to make some acknowledgements to my friends Claude Doppelslash and Sans Mihayevs for helping me out with in the narrative AI and formal logic fields. And I would like to thank my platinum sponsors, my daughters Felia and Eva and my wife Laura, for their time and budget for this project. And thank you all so much for your attention, since this is my first presentation at an academic conference. Thank you. Any questions?
So I had a question.
Yes.
So do you have any projects or examples that you could point to where you tried to use DEL and like sort of what your experience might be? Because like I guess one of the concerns, you know, for people who might not be familiar working with different kinds of logics, you know, it might be very intimidating to start. You know, it's like where do I start? You know, what kind of logic do I start with? Do you have any sort of
These three implementations I've mentioned are probably I don't know if they're the only implementations, but they're working implementations that can be played with. And Edgar and Martins have applied it to a real game, actually. And they can be taken directly and experimented with. Probably, I'm taking currently a look at SMC-DEL because it provides much higher performance when compared with pure model checking, as in the demo model checker, which is which was the previous implementation of dynamic epistemic logic. Thank you. Okay. I'm done. Thank you.
With that.
Yeah. This one?
That's me.
Sweet. Okay. Hi, everyone. My name is Michael Green. This is like my second official conference, so I'm still feeling kind of new to it, so I'm a little nervous. So if I speak too fast, just like tell me. And I'm here to present Press Space to Fire, automatic video game tutorial generation. Like I said, my name is Michael Green. I wrote this with Ahmed Khalifa, Gabriela Barros, and Julian Tegelius from NYU. So the first question is why are we trying to automatically generate tutorials? Why is this an AI problem? And so if you look at video games as a whole, at least really good ones or even just normally decent ones, they all have them to an extent. They somehow teach their players how do you play this game. It's often the first thing that a player sees when they interact with the game, and it teaches you what's necessary to continue playing that game, right? The thing is that they're really time-consuming and or expensive to make, so you normally push it off to the last minute and it doesn't get a lot of time, or you know they end up looking really, really bad. And these two reasons alone are a pretty good reason why this would be a good AI problem. If you could automate or at least semi-automate tutorial generation, that would make it a lot easier for game designers. But then we're also interested further in maybe a new role for AI, which is that of a teacher. I'm really interested in what video games can do for learning and what AI can do inside of that. So if we decided to throw AI at that problem and made AI a teacher for human beings, that could be something really interesting. And then of course that begs the question, if AI can teach games, what else can it teach us, right? So we're going to start off with the types of tutorials. In our paper, we decided to go through a quick summary of what we believed were the scale, the scope of tutorials as a whole. And so we have these three main types. These aren't all inclusive, but they're pretty prevalent in most video games. So we have our first teaching using instruction, games like StarCraft. In this particular instance, I brought up Civilization. And this is where the advisor is actually telling you, here's what you need to do this thing. It's basically instructing you, this is what you should do in order to do this thing in the game, right? The second would be teaching using examples. This is a scene from Mega Man X. In this case, you're not actually playing this part of the game. This would be typically something that is shown to you by some sort of NPC player. And in this case, he's describing how to charge up his Mega Shot, which he's doing right now. And he missed. Always. It's okay, buddy. So teaching using examples is our third one. Excuse me, our second one. And then the third one is teaching using a carefully designed experience. And the best example of this is, of course, World 1-1 from Super Mario Bros., where you're literally learning how to jump and how to move inside of the level. So how do you generate a tutorial? For this particular instance, we're going to assume that we're using simple arcade games from here on out. The first thing that you need to do is you need to use an agent to discover game mechanics. Now, what we mean by game mechanics is we mean things like movement. How do you control your player? Here, we're using Space Invaders from the GVG-AI framework, which we're going to go into a little bit later. And you're learning, you can move left and right, and you can shoot bullets. You need to learn interactions between objects or sprites in the game. I just got hit by a missile, so I died. I'm able to shoot missiles at aliens, and they'll blow up other aliens. And termination conditions, basically how do you win and how do you lose a game? These are things that you need to teach the player how to do. And of course, other miscellaneous things like score or points would be other things that you'd be interested in teaching your player. The second thing you need to do is you need to form some sort of mechanic graph. That would literally show, in this case visually, but describe how things are related to each other inside of the game. So here for Space Invaders, we have the avatar, which shoots missiles. Missiles kill aliens. Alien kills the avatar. And then, of course, for this Terminator down here, we describe our termination conditions. So we win if we kill all the aliens, and we lose if there is no more player because they got destroyed by aliens. The third thing that you need to do is you need to trace this graph that we just created to find critical paths. Ooh, that's not playing. I'm sorry about that. There we go. So here we start off, we start this Terminator right here, and we realize that if we trace this up from our victory condition, we end up with alien. We quickly realize that the alien score counter will decrease if it gets killed by missiles, and we realize that the missiles will be shot by the avatar, and that would be an example of what we call the critical path. So we form that over here on the left. And then, of course, there's the opposite of that, which is finding a critical path failure. Why won't that play? Sorry about that. Oh well. I'll point it out to you guys. So here, the Terminator would realize over here that if we killed all of the avatar, then we would lose. And then what kills the avatar, well, that would be aliens, so that would be a critical path failure. And then the fourth and final thing that we need to do is we need to use these chains to create a human-readable tutorial. So this is a quick example of really simple grammar. This is definitely not all-inclusive for everything that you need inside of it. But in this simple situation, we can describe the controls of Space Invaders. So we can say, press left and right to move. Or we can say, hold the space bar to shoot. And then from a grammar, you'd be able to build using these chains that we just created and other information that's contained within this graph. You'd be able to create an entire tutorial out of that. So we said future work that we'd want to use the GVG-AI framework. This contains a collection of games. I'm about to go in that a little bit later. And then we'd build a mechanic graph using the video game description language contained within each game inside of the GVG-AI framework. And then we'd build a grammar that would create human-readable tutorials based off of all that. But what I said before, if you remember from number one, we actually need to use an agent playing this game. Right now, we'd kind of be cheating if we just use the video game description language, because that's basically having raw data from a game. So instead of doing that, we decided first we were going to cheat, and we're going to see if this graph can work the first time, and then find an agent that can discover these mechanics on our own. So the GVG-AI framework that I just mentioned, I'm sure a lot of you have probably heard about it before, but it stands for a General Video Game Artificial Intelligence Framework. It contains a large selection of games from which we can train this thing on and prove its worth. And all these games are described in Video Game Description Language, or VGDL. VGDL kind of looks like this. It's made up of 4 different parts. There's a level, which actually contains all the information about where sprites are contained on the level. There's a sprite set, which contains all the information about sprites. This is Zelda, which is contained in the framework. So you have things like spiders, you have keys, you have walls, you have an avatar. You have these interaction rules, so things like if the spider collides with the hero, then you die. And then a termination condition, like if the avatar dies, then the game lost. And from these 4 parts of VGDL, we can actually use this to construct a tutorial. So after we finished writing this paper in July, we actually went ahead and decided to try some work on it. This is very preliminary, so don't judge it. But the current output of Zelda with our tutorial, so you can't actually see the tutorial graph from this, but this is an example output of following these interaction chains, these critical path chains that I was describing earlier. There's no grammar involved with this now, we're still building it. But so you see here, you are the shoot avatar, press the arrow keys to turn and move, use space to shoot in the direction that you are facing. So that information is contained inside of the avatar itself. We can just parse that right out of there. And then here we say the goal of the game is to get sprite counter goal to 0, and not get sprite counter no key to 0, and not get sprite counter with key to 0. And what that means is that the no key and the with key are actually the hero with or without the key to unlock a door in Zelda. So we start here. It's kind of tricky because you actually have to read it up. So this bottom mechanic no key, offshoot mechanic with key means that if I collide with a key, I turn into a with key hero. So now I can unlock things. With key can now kill the goal, and we terminate if we kill the goal. And information like that. It kind of reads up from there. You can see these other 2 are the critical loss paths. So if the avatar ever dies, no key or with key ever die, then we lose the game. Yeah, and that's all I have. So thank you. Yeah.
So I have 2 questions.
Yeah.
First one is, by revealing critical paths to either victory or failure, have you spoiling the game?
Well, so typically within a game, one of the first things that revealed to you in a tutorial is how to win, right? So if we didn't want to show all of this information of you need to do all of these things, right? If it was really, really cut and dry, like you need to take this path to get to the goal, then yeah, that would make a lot of sense, because that basically say Mario should take this path on World 1-1 to get the most points and ultimately win. But in this case, we're listing off simple mechanics. So we're not, I wouldn't exactly say that we're giving it away so much as we're assisting.
Okay, the second question was, have you played Far Cry Blood Dragon?
I've not, but I've played Far Cry 3, but I know it's not the same.
So Blood Dragon, they actually make a lot of fun of tutorials in video games.
Do they really? All right, I'll have to try that out. Thank you. Yeah.
As a game designer, one thing that's very important for me if I build tutorials is to involve the player at one point. Players, actually, because you don't just build tutorials to lay out the mechanics, but you really want to see how players react to the game.
Right.
And how does your model cater for that? So how do you have plans to involve real players at one point?
Yeah.
Or are you just going to simulate this, or how do you have
Yeah, so I'll repeat the question because I totally forgot to do that for the last question for the stream. So basically you're asking, do we have future work involved to involve the players inside of tutorials rather than just...
Yeah, because also for me, observing the player
Yeah.
is the only way I can make a tutorial really work.
Absolutely. Yeah. So right now we're focused on just making text-based tutorials, which really wouldn't have much player input from that because, you know, it's just something that you read. But later on we want to eventually, I was describing earlier, if we go back to the types of tutorials, we'd want to also include these other examples. And of course, teaching using examples, and especially teaching using a carefully designed experience, you would need player input for that. So yeah, that's something that we're interested in checking out.
But how do you involve the player? Do you have any ideas already? Or
No, not yet. No. Yes.
I was wondering if you considered flipping your pipeline, and whether you thought that was sort of from a tutorial, and we use that to teach an AI to play the game.
So the question is, would we consider flipping the pipeline to use a tutorial to teach an AI to play the game? That would be really cool. So that's not, I mean, again, we are not doing that currently in this paper, but that's definitely something we could check out in the future. I know that there's some other research in the Game Center at NYU that's interested in doing that. But yeah, that could be a potential future plan. Question? Yeah.
There are a couple more types of tutorials that occur to me that I wonder if they would kind of fit within your framework.
Yeah.
One type is progressively complex levels, like in Portal, where you start with a very initially simple level and gradually
Right.
building up mechanics. Another type of like a type of scaffolding where the player initially is given lots of support. Like I think in Mega Man X, they have all the weapons at the beginning, and then that is faded away, and they no longer have all those capabilities. Could those types of tutorials, do you think, fit to this framework, and maybe that would connect to the earlier question about how the player might be involved?
Yeah. So the question was, maybe there's some other tutorials out there that would they fit in these frameworks, and one of them was like scaffolding, type of tutorial, and then another one. What was the second one? Increasing levels of difficulty. That's right. So I guess both of those, in a way, could be considered a carefully designed experience. Which I vaguely describe that as Super Mario Bros. But at the same time, you could basically say that those would definitely fit into a designer who went in and said, okay, what would teach the player the best? And so that would be an example of a carefully designed experience, because you could start that from either end. But yeah, that's a great question. Yeah.
So one of the problems with tutorials is that if they suck, they can be kind of belittling. Like, there's nothing worse than I know what to do and the AI computer is telling me.
Yeah, I completely agree.
So Mega Man X, the intro stage is actually like World 1.1 is always the master class for that. But Mega Man X, there are certain segments where you literally can't do anything that won't teach you a mechanic. Like there are sections where if you move around and just do things, you will get what to do. So tutorial isn't just not necessary. It's like strictly like it would be bothersome, it would be irritable to actually have the computer be like, hey, at this point you should jump and try to do the wall dash.
Right.
That would just make the game experience worse.
You're right.
So there's another question here. Is just like if you sort of enumerate all the things you're supposed to do, how do you go? Well, this is stupid obvious, so I don't actually need to tell the player this. How do you sort of like trim those things out?
So that's a good question. So the question was basically if we have a bunch of information in there that's not really necessary for the player to know, and would be tedious to teach the player, right? So right now I haven't been able to solve that question yet, because it's actually something just within the GVGAI framework. Even though those games are relatively simple, there's some information in there that's just like you don't need to know how to do this, like because it's behind the scenes, or it's stuff that just would be inherently obvious to know how to do. That's something that we're working on right now. If you have any suggestions, we can talk offline about it. But yeah, that's something we're trying to work on. Questions? Yes?
You got time for one more. So you said at one point that you want to move away from directly using the VGDL in the future because it's cheesy.
Yes.
But as a game designer, if I'm creating a tutorial, I obviously have access to information about how the game works. So I wonder if you could say a bit more about your justification for saying that that's...
So, yeah. So I guess, we mentioned earlier for the stream, that we wanted to move away from VGDL to an agent playing the game. And the reason why we want to do that is because we want to assume, for this sake, that we have eventually some sort of human-like AI that's able to play this game and then teach a human how to play the game like a human. And if you have direct access to this information, like the VGDL is literally just listing off what the game is. It defines it. And if you have access to that information, that seems almost like you're cheating in a way. I guess it's more of like an honorable thing. I don't know. But I feel like from an AI perspective, it'd be more interesting. We might get some more human-like playability if we use an agent to actually play the game rather than just reading the game information. That's what we hypothesize. Does that make sense? Awesome. All right. Awesome. Sweet. Yeah. Thank you guys.
All right. It is time for the final talk. Yeah.
And I'm presenting an actual physical object, so I brought some examples of that physical object.
Yeah. So if you're on stream, sorry you missed out on the physical objects that Kate has.
Well, you can go to Generominos and print out your own.
I'm not sure the mic can get you from here.
But here you are.
All right, hello again. So many of you who are here for my previous talk, which is about the sort of generative framework for generativity. And I mentioned during that talk that this framework, which is about kind of the data transformations that go on in a pipeline of a procedural content generator, can be modeled as you have a bunch of inputs and you have a bunch of outputs, and then you chain a bunch of those together. And it turns out you can do this quite physically. So this is work that I'm presenting that was performed with myself, Edward Melser, and Michael Matthias, and Edward is at NYU. So yeah, these are ideation cards for interactive generativity. As I mentioned before, this is based on the idea that generativity is a pipeline of data transformations, and you can read our previous paper for more. But these are ideation cards. So who here is familiar with the concept of an ideation card? Okay, a fairly small number of people. So the idea behind an ideation card, so here are some on the right. Oh, I don't think I have my citation in there, but these are Brian Eno's cards from, I think, the 1970s. He was an abstract musician, and to kind of get outside of the ruts that he was thinking in music, he made these cards, each of which is a little provocation. So things like use non-musicians, use fewer notes, emphasize difference, honor thy error as a hidden intention. And then if he was stuck on a piece of music, he could draw a card, and there would be sort of an external push that he might have been resisting subconsciously. So the neat thing about ideation cards is they're kind of either giving you ideas or suggesting things that you might not have otherwise. And often, like, because they're physical objects, you have a bunch of neat features. So you have things like accidents and providence. So I can draw a card, and that card might be meaningful, or I might just tell myself that it's meaningful because that was the card that fate gave me in that moment. You can also have things like juxtapositions, where I can draw two cards and lay them next to each other. So those two cards will maybe, if it's like use non-musicians and take a break at the same time, it'll be telling me something kind of interesting in the space between those two cards. They're tangible objects, so you can like pick them up and pass them around, and you can do interesting improvisation with them. So if you'd like to know more about if you'd like to know more about ideation cards and kind of this whole, it's like a whole genre. Every field has ideation cards in different ways, some more or less sort of concrete. There's a really good taxonomy of ideation cards that's linked to there. Not a lot of these cards use spatial relationships. Who's played the metagame? Oh, very few people. The metagame is something where you are laying down cards and you're kind of looking for the relationship between various nerdy nouns. And like there's actual spatial relationships between the cards. But ideation cards usually don't use that. My cards do, because they're actually building a pipeline. So the way these cards work, if you're able to like hold on to it or like see a deck, so these are about building pipelines. So you're going to use these cards to build a pipeline from the input cards, which have a red stripe in the top, to the output cards, which have a blue stripe in the bottom, with data transformations creating a path along the way. Information has to come from a source, no magical informations, although you can always say, like, if there's a number, you can always say, like, random number generator. And data can't magically change type. So you can't have information that goes from a number to a 3D model, because you have to have some way to convert a number to a 3D model. And you might have a card that says convert a number to a 3D model. That's cool. So yeah, your cards will look like this. They have some information on them saying what that card represents. And then importantly, they have their data type. So this is the output. So this stock market data outputs a number. Here's a jet of fire. And that takes the amount of propane that's currently being given to that fire effect. So as the stock market goes up and down, so does the fire. So here's a piece of art. That was actually designed by one of our students in the test that I'll be talking about later. There's also a couple of other options. These were like, it's kind of interesting to me making a game that is supposed to represent accurately something in physical reality, because you have to like make it fun, but you can't make any sacrifices to not represent what's real. So you kind of have these things where it's like, okay, the data is transforming vertically, and you can stack things kind of off the side. But then the input cards also have these little sensor things, which is who is using the sensors. So text is a type of content, and you can put an input modifier that is text from a particular user, which means that there's a person involved, and that person doesn't know they're controlling it. So this is text from somebody who didn't know that they're a part of this artwork. The top one is an accelerometer, which is held by a person, which is actually the artist. So you can kind of build these semantic things. There's a whole bunch of different data types. This is, again, that how do you balance good gameplay and accuracy for very advanced people and accuracy for not very advanced people. This is also like a deck that is intended to teach novice students what they can build with PCG. So there's like a whole bunch of different types of data. The ones that are the same color are kind of comparable. So you can, like, if you don't have a card, you can guess that you can probably socket those two in. So I'm just trying to do a little bit of UI there. I also, not in this deck, but I also have a deck of idea cards, grant cards. You can use this to play grants against the humanities, where one person draws a grant card, and then the other players have to construct a grant proposal, and then they decide which one wins the grant proposal. These are actually, so all of the cards in the deck and all of these cards are taken from actual real-world examples of interactive generative art. So for an example, this is actually one that Michael Matthias kind of built accidentally when I told him to play with these cards. So this is a NeuroSky Mindwave, which is one of those little like headset thingies. It measures your brainwaves, which gives you 5 numbers. All right, 5 numbers. There's a procedurally generated flower, which is basically something that like makes a 3D model of a flower with length and width of the petals. And that takes in 3 numbers. Cool, we use 3 of those numbers. You can always discard extra inputs. You can ignore inputs, right? And that gives me a 3D model, and I'm going to render that model to stereographic VR. But the user doesn't know they're controlling it. So what this piece is, I really want to build this, is the user the user is in VR and has like an attractive 3D printed flower in front of them, which they're contemplating. They don't know that their brainwaves are getting measured. And so as they're contemplating this flower, the flower is blooming in response to their contemplation. So I thought that was a pretty neat design. They're also really good for studying kind of why are some things harder to develop for than others. Who here has developed games? Fair number of people. Who here has developed games for weird controllers? Fair, not very many people. Who here owned a Kinect? Who here owned a Leap Motion? Who here owned a Guitar Hero controller? Yeah. Funny how that works. So why does the plastic, so there's kind of a question that I had because I really enjoyed the Leap Motion and the Kinect. Why are they so hard to develop for when the Rock Band guitar is so easy? Well, here's a card that's pretty common in this room. It's called Play a Video Game, and it requires events and states. So like I'm pushing down a button or I'm holding down a button. As long as you've got that, you can play Mario pretty effectively, and you can also play a whole bunch of other different rhythm games. And look, Rock Band guitar gives you events and states. Cool. A gamepad gives you events and states. Cool. A DDR pad gives you events and states. Cool. Like, everything just works. A Kinect gives you a depth map and some vectors. Oh. Well, how about the NeuroSky Mindwave? A bunch of numbers. Oh. Leap Motion? 3D model of your hands. Those don't plug in to play a video game. So what everybody who, so if your boss says, okay, we've got Shoot 'em Up 4000, I would like you to port the Shoot 'em Up 4000 to the Kinect because we hear that's the next big deal. And everybody had to go through kind of these other cards that compressed or made the data less interesting or less continuous. And that's why making Kinect games kind of sucks. So I took this as a provocation to design my own Kinect game, or my own Leap Motion game, actually. Something that would work really well, and I took it to an arts festival, and kids loved it, so did stoners. And kind of the abbreviated version is on the left, on the right is the full version, but it's basically you take the Leap Motion, that gives you a bunch of joint positions for your hand. What can I do with positions? Hey, a Voronoi diagram takes positions and makes you some attractive polygons. Then I draw those polygons. Solved. And that's pretty much that piece, is just finding something that sockets really well into the Leap Motion. It took me about an afternoon to make. So we also tested these with our students. The students really enjoyed them. They seemed to like them. They definitely, as a TA for that class, the students seem to be making more interesting projects after these cards than before these cards. A lot of their previous games were you have a game and there's a button, but the button is made out of cardboard. With this, they were making much more interesting stuff. And you can read more about that user study in the paper. These are some examples. I won't go into the other ones, but yeah, So they chose a provocation card and tried to build things. They didn't always figure out, like, I wasn't apparently good at explaining some of the things. Like, this is one where clearly they didn't get that you actually have to match the symbols, that the data transformation is important. More advanced users, especially users who've done generative stuff before, seem to get the, like, you have to match the symbols because you can't magically transform data. But that's a lesson that I'd like to teach students. Yeah. Anyway, I have now printed these out, but they're also Creative Commons. I have a couple of decks here to sell, and maybe they'll come soon to Kickstarter, because right now they're $25 a packet, and I would like to get them down to like 7. But yeah, any questions? Oh, and I guess a couple of things that I meant to mention. I already went into, so this is a really nice project to build because I did it all based on JSON that went directly to HTML divs, which then I made a Python thing to automatically export to PNGs. So if I want to add new cards, all I have to do is edit the JSON. So this afternoon, I edited the JSON to add word to vec and Alison Parrish's new pronunciation thing. So now you can convert words to vectors in interesting ways. And I can tell you more about that in some, if anybody is interested in actually like iterating rapidly on physical prototypes. That was a super nice pipeline. Any questions? I'll have these on me, so come play, build things, design bad things. Everybody wants dinner or drinks. Anything from the stream?
The stream's been quiet recently.
All right.
It's been really quiet.
So,
all right, shall we call
one last round of applause for the speaker. And with that ends day 1 of EXAG.
So just a couple of announcements again. If you're presenting tomorrow and haven't sent your slides to Joe, please do so by 9 o'clock tomorrow morning. Tomorrow we're going to resume bright and early at 9 o'clock tomorrow, 9 o'clock in the morning, with some industry case studies. So we've got some actual game industry folks who are going to give us some presentations on things like Dwarf Fortress and AI personalities. We'll have a couple more, yes, we will have a couple more long paper presentations before lunch. And then the rest of the afternoon will be dedicated to a variety of demos. I believe there are 6 total. So, yeah. So please feel free to check it out. And then after all demo presentations, there will be just demos open for the entire afternoon. So,
yeah.
Thanks again for stopping by, and feel free to go grab some dinner and play around with some cards and stuff.